And we'll move to the next question, question number 1.29, electrical field and charges, class 12. Additional exercise we are doing it. These are very much important for your competition exam like NEET and JEE. So the question number 1.29, what they are saying, a hollow charge conductor has a tiny hole cut into its surface so that the electrical field in the hole is sigma by 2 epsilon naught and n cap, where n cap is the unit vector in the outward normal direction and sigma is the surface charge density near the hole. Now, what they are actually saying, a hollow charge conductor they don't give us the shape, so we can take arbitrarily as per our wish. Suppose one spherical conductor we take like this, okay, and one tiny hole on the surface. Suppose this is one tiny hole in the surface, and the surface charge density they are saying sigma, means it is the Q by A, areal charge density sigma to this. Suppose maybe we can say this is a positive charge if we consider like this. So it is the number of charges, amount of charges per unit area, sigma is given. Now they are saying we need to find one point near to this tiny hole nearby area, very near to this area of the tiny hole. What could be the electrical field? Electrical field that we need to calculate or derive. So here you see, we know from Gaussian surface, we'll do this in a 2 points. We'll consider 2 points to prove this one. One point will take inside this conductor, maybe any point, and another point will take nearby this hole outside this conductor body, and initially and at start will take this, it is without the tiny hole, it is a total conductor body, and the area it's a tiny, so we'll say this is dA. We'll take it as the area of this tiny hole, it's dA. Okay. Now we know phi net from the Gaussian theorem. What we know, phi net is flux, net flux outside this body. Suppose this is point B, the electrical field, and this is EDS, and divided the area is this one, so we'll say this is EDA, and this is nothing but, if we consider a Gaussian surface outside this conductor body, and this is will come Q by epsilon naught, we know this, and Q is here nothing but the small area charges, so we'll say this one E equal to sigma into this one small area dA over epsilon naught. So this small area cancel out both sides, so the electrical field, if we say the mod value this one, so this is sigma by epsilon naught, the overall this one. Now here if you consider this one, this electrical field, actually the overall electrical field, this one overall electrical field, this is overall, will get, just to see for a conductor body, this one means the area remaining area without the tiny hole, it will contribute one electrical flux. Suppose this is U1, and flux or electrical field due to this tiny hole E2, and this E1 and E2 collectively, they will produce this overall electrical field. If you say it is in vector form, and there this is also tangentially perpendicular to the surface. E1 we say the conductor body due to electrical field, conductor's body, and E2 is the field due to tiny hole charges on the tiny hole part, and both are in the same direction perpendicular to this tangent of the surface. So value, you can say this one, U1 plus E2 equal to electrical field E, because these are parallel, theta in between is the 0, so it is the simply addition, we can say. Okay, vector is the magnitude will be simply additive. Okay, now this is for the outside point B. If you consider like this is coming like this. Is it for the outside of the conductor body, and it is nearest to this, very near to the tiny hole. Remember this one, very nearest to the tiny hole, but outside, but it is outside the conductor body. Now if you consider the inside part of point A, this was point B. If you consider the electrical field at point A, in that case what will happen? So these tiny charges will put another field this side also, because this is a point charge. You can consider as we took this one is the smallest one, dA, very small. So some charge it will contain. So this part will give you some electrical field this side also, and this will be E2. And the remaining charges of electrons deficiency here, positive charge, test charge, if you put here test charge plus 1. So remaining all these charges, the charges will repel each other, and simultaneously it will produce one electrical field this side also, but it is in the normal direction of this one inside. And the overall electrical field inside point A, this will be E1 minus E2. This will be subtractive, and as they are also parallel, they will simply subtract, and this will be the inside overall field, net field inside the conductor body. Net field inside the conductor body, what you know, it is 0. Inside the conductor body field is 0. Again I am repeating, this tiny surface will also, which one producing E1 field outside the body. Similarly, because of this is a point charge around, like this is a very point charge, so this will again producing this one E1 this side, this is E1 and this is E2. E1 also this side, here E1 and E2 are both same direction outside, and here E2 is always will be working outside, whereas E1 due to this conductor tiny holes consider, so this will working inside. And as we know, the property from the property of conductor, inside electrical field of any conductor is 0. So this sum of this or subtract of this, you can say this sum like this, you can say like this, E2 is this direction, E1 is this direction, so this is 0. What does it mean? Actually E1 is equal to E2. That means the electrical field due to this tiny hole is equal to electrical field created by the total conductor body without tiny holes. Now if you replace this one, as the tiny hole is not really exist, but as per our problem, we consider hypothetically that there was a without tiny hole, there was a metal body, conductor itself, part of conductor, which is having dA surface and having some charges. So as in reality there is no E1, E2, there is no E2, so this one is G2 actually, because we consider tiny hole is G2, so this is G2 and this is E1, So as this is not available actually, so we will say U1 plus E2 is also U1 is actually the net electrical field outside at the point of B from the equation 1. What does it mean? Actually 2E1 electrical field due to conductor body will be overall electrical field. What does it mean? The U1 due to conductor body is nothing but the half of the overall electrical field. And if you say this is the vector from direction, so E1 vector is equal to half of E vector and n cap, like this. If you put the direction, this will be n cap, and then if it is putting the n cap, it is taking care of your direction, so you can put like this only, mod of E1 is equal to half of mod of total electrical field and n cap. Now we have got this one earlier, electrical field overall is here, it is half of sigma by epsilon naught, and it will be n cap is there. That means the electrical field outside this body, conductor body, is nothing but the half of the sigma by epsilon naught n cap, half of the electrical field generated itself by the conductor body, because conductor body itself is generating this much of overall electrical field. And once you cut this one teeny hole, this electrical field nearby the teeny hole actually got reduced by half, and the question itself proved. Question is proved what they said. Electrical field inside this one, the extras, and the value is coming sigma by 2 epsilon naught n cap. Proved. Okay, thank you. Next, we'll move to the other question. And the question is they are saying Q number 1.30. Obtain the formula of electrical field due to a long thin wire of uniform linear charge density E without using Gauss law. Hint, they have given use Coulomb's law directly and evaluate the necessary integral. Obtain the formula for the electrical field due to a long thin wire of uniform linear charge density E without using Gauss law. Okay. Now we see they have given one long thin wire